Recording in progress.
So the assignment was like create a class product which has a method calculate product and which takes two integer parameters and which computes the product of the numbers, and then we had to like overload the same method with double type of parameters, and then we needed to like create objects of those of that particular class and invoke both the methods. So let me just demonstrate that here. So we have a package overloading. So I've created a class called product, and then I'll create one method calculate product, and we need to compute the product of both the numbers. Let's print this product as well. We need to again overload this method for double type of variables. So I'll create the same method. See, now we are getting an error, right? Why we are getting an error? Because the signature of the method is similar to what has already been defined. So we need to either increase the number of parameters in the second method, or we need to change the data type of the methods. So that is what method overloading is. So what we'll do basically, we'll change the parameter data type, and now if we compute the product of two numbers, it would be also double. So see, we have a method of void return type. Void return type means this method will not return any value to me, and this is the name of the method, and these are the two parameters. We are taking two integer parameters, num1 and num2, and we are basically computing the product of both the numbers, and then we are printing out the product. Similarly, again, this is also the same overloaded method. See, this is a return type is actually void, so it does not return any value. This is the same name of method which we had already described, which we had already defined here, and it takes two double parameters. We are computing the product, and then we are printing out the product. So now we need to invoke both these overloaded methods. So what we'll basically do, we'll basically create the object. This is how we create the object. Class name, reference variable equal to new product, and product dot calculate product. So if we pass to integer variables, so it will invoke the method at line number 5, that is the first method, 3 5, and again let's run this program now. You can see that the product is equal to 15. So it actually called this particular method, the first method. Now we are passing to double variables. 4.5, 2.0. Let's run the program again. So it invoked the second method, which had two double parameters. So Java compiler actually identifies based on the type of product, based upon the data type of the parameters, like which method needs to be invoked, or the number of parameters. So this was the assignment which we had to do, and these are called overloaded methods. Both these methods are called overloaded methods. So this is basically in application, in real time application, you might see that sometimes you need to perform the same type of operation but for different data sets. Suppose some of the data sets are like integer, some of the data sets are basically double or float. So in such scenarios, you would need this kind of application of method overloading. This was like straightforward. We'll go ahead with the next assignment. So the next assignment was basically on constructors. So try to like understand constructor. This is a very important topic, and going forward everywhere there will be like application of constructors, and I'm teaching you constructors again. It means I'd already demonstrated this demo last time, but again I would uh, create one more class and just demonstrate how basically constructor works, such that means you get hold of it. This is a very important topic. If at all you had not tried out the last class assignment, kindly go through all the demos and try to like practice as much as possible. So the assignment was basically we needed to create a class named player. Yes, who is this? Yeah. And
Yeah.
yeah, play.
I have a question from the method. We have two web metrics for in a double so
Guess so.
calculate products
Guess so. Your voice is breaking. Yeah.
or really okay. Let me.
What?
Now it's good. Are you hearing me?
Yeah, I can hear you. Yeah, yeah. Please go ahead.
Yeah. My question is from the method.
Why you don't understand? Okay, do just one second. Guess so.
I think Master Rasha. Can you?
Can you please mute yourself, someone?
I'm scared.
Okay.
I think Master Rasha.
Hey, Masresa, can you mute yourself?
Sorry.
Okay. Yeah. Yeah. Guess so. Please go ahead. Yeah.
Yeah, my question from method word method.
Yeah.
We created in the class before main method. So is there any difference we created after main method, or it must be inside in class? This two void methods.
So, sorry. We created this outside the main method. That is what you're asking?
Yeah, this is created inside the class. Yeah.
Yeah,
So can we
inside.
create it? Yeah, can we create it inside main method, or what is the difference between created inside the class and outside for the main method?
Yeah. So see, any method that will basically create will be created inside the class and not within the method. See, this is our first method, right? This is the second method. This is the overloaded method. See, main is also a kind of method. This is main is also a method itself, but this method has special meaning to the Java compiler. Because why? Because see, what is the difference between these methods? There is some difference. In this method, to call this method, we basically needed to create a object of the class, and using the reference variable dot method name, we are basically calling the methods, these methods, right? But see, this main method, public static void main, this main method, right? We are not, we don't need to basically create any object in Java to call this method. So that is why this main method is special, and we don't need to basically create a object of the class to invoke this method. This is also a method. This will be within class. This is another method. This will be within class. We won't be creating this method inside the main method. But yeah, definitely we can call this method. We can call this calculate product method within this main method. And how we basically calculate, how we basically call this method is using the reference variable of the object created. Got it, Gasa?
Yeah, but if we try to void method inside main method, it will be work. Yeah, it will be work fine.
Sorry.
Even can we try for void method inside main method? It will be work.
No, it won't work.
Is it work?
No, no.
Oh,
No, you don't create the methods like this inside main method. I'll show you like inside main method. See, now these are like non-static methods, or this is also called non-static methods. So non-static methods, when I say like non-static methods, right? See, there's some difference between static methods and non-static methods. Static methods I will cover in some time, but the difference is static methods have a static keyword in before their return type. We don't have any static keyword here, right? So basically this is a non-static method. So to call a non-static method, we will always create a object, and basically then we'll, using this reference variable, will invoke the method. And I will teach you how to create static methods. And for static methods we'll see some difference. We will not require this object, we will not basically require the object to call the static methods. I'll teach you why in some time, but this is the difference. So you can basically invoke this uh, non-static methods using the reference variable. Got it?
okay. So such means the dynamic, or it is not.
What is dynamic?
So where said non-static the void method is, so that means dynamic or what?
You mean to say like this main method is dynamic?
I don't know. The meaning of non-static shows that means the dynamic.
No, I'm not clearly getting your question.
Even for my understanding now, you said for the non-static, yeah, non-static method is. So non-static method is the meaning of to void a method is the value is dynamic or what?
Yeah, see, these are both non-static methods, and non-static methods are basically, we don't like say static versus dynamic here in Java, but
Okay, okay,
okay, but
okay.
see, it's not like static is something at rest and dynamic like something, but yes, see, there is some difference. Like this is a non-static method. Understand that non-static method is a method which does not have any static keyword in the method signature. So in the method definition you do not see anything static. So see, here this method has a static keyword, right? Similarly for static methods you will have the static keyword. So that is it. And there are special cases where we basically use static methods,
Thank you.
and there are special cases where we basically use this non-static method. So I'll teach you when we'll basically go for static methods and where to like basically use like static methods. Okay. Okay, TJ was asking, can you please try this argument 2.2? Okay, I will try out 2.2 and yeah. Okay. Why I'm getting this extra points 4.84000, and one more question, why we need double product is equal to A into B. Okay. Okay, double is precise. Okay, 1 second. Okay, TJ, I'll get back to you why basically we are getting this one at the end. Okay, 4.84 is what you were expecting, and this might be due to certain precisions, but I'll get back to you on this one. And one more question, why we need double product equal to A into B? So a product we basically compute like A into B, right? Means you have two numbers and then you compute number one into number two. So there shouldn't be any issue, right? What is your question? So this is a simple product like number one into number two, or like A into B. If you have two numbers, just compute the product and print out. So that is it. So this was a simple example of method overloading. You understood method overloading, right? Either you can have the same definition, and what you can basically do, you can increase the number of arguments or change the number of parameters, change the data change the number of parameters or change the data type of parameters, and based upon what parameters you are passing, Java compiler will identify and call the respective methods. Okay, so we had like another assignment where we basically needed to create a class player which has some attributes like name, age, salary, and then we'll have to basically create a default and parameterized constructor to initialize the data members, and then we'll basically create some objects to call this. So I'll create a class player, and basically we need attributes like name, age, salary. So what will be the data type of name? Name will be basically string, so it would be string. Then age, so age can be double or integer based upon, let's take age, and then we had something called salary, private, float, or double you can take for salary. Say we had studied about this private, public, default, and private, public, default, and protected access specifiers in the last class. See, for the security purposes, we will basically keep this variables scope as private, because as of now I don't want these variables to be directly exposed to other class. I had taught you in the last class about access modifiers in great detail. I had shown you like demos for all the four access specifiers. Anyone who has like missed last class, kindly go and see the YouTube recording, so you can like get hold of this, like why basically we use private, protected, default or public. So in this case we are creating a class player, and as of now I don't want these attributes to be exposed directly to other classes. I want this to be used only in this class. So in that case, what basically we which access modifier should we use? We should basically use private. So also, like going forward, when you create the projects, generally what you will do, you will create most of the variables as private most of the times. And if you want to like expose this, you will see like how we basically create getters and setters. So we'll create one constructor now, and we'll create first one default constructor. We'll provide the keyword public, we'll provide the access modifier public, and then the class name. And default constructor does not take any argument. This is default constructor. This does not take any, no arguments. We'll assign some name here. See, basically what we are doing, we are initializing the data members or initializing the instance variables. So I'll repeat. So when I say these things, say these terms next time, you should basically understand these are basically instance variables or non-static variables. Whatever is declared here at the class level, these are like instance variables or non-static variables. So or you can call them data members as well. So we are basically assigning values to the data members. Now there is another way. We will basically create parameterized constructor, and parameterized constructors are very useful. Why? Because you can create the objects and provide values at runtime. So that is why we basically create parameterized constructors. See, this is public player, and again, what is the difference between parameterized and default? This parameterized constructor will take arguments. This will take string name as argument. This will take string age, sorry, double age, and float salary. Now we'll do this dot name, this dot age, this dot salary. Now we'll basically create a main method, and when I create an objects and don't provide any value, so which constructor will it call? So this will basically call constructor 1. this is the constructor that will be getting called. So if I print out player name, what you will basically get? You'll get player name KT, because this constructor, this does, we are not passing any parameters over here, right? So when we don't pass any parameters, the default constructor will be called. And what is the value that we provided? What is the value which we used for initialization of the instance variable name? We provided a value of KT. So this constructor is getting called and the string name has a value of KT. So when I do like reference variable dot name, it will give me this value. Now next, what I will do, I will pass some values. I have taken down this topic again because this is like very important and I'm saying you this repeatedly. So try to like practice this as much as possible. We'll again print p2.name. So this time you'll get player name Robert. Why? Because we created another object, we passed some parameters, and see, the order of the parameters should be same, because the first parameter is expected to be a string, the second parameter is expected to be a double, so I have passed a double, and the third parameter is expected to be a float. So basically we need to pass a float. Can anyone tell me, like, this is double, but I have just passed an integer, it is still not throwing me an error? Why? You see this, right? This is an integer, I have not given dot zero, but my data type expected was double. Can you let me know like why this is not throwing me any a compile time error? Anyone? Okay,
You mean, I think the same, right?
sorry.
I mean, both of, int and
No, the first age is 20.5. So
No, this 55 is an integer, right? And
integer.
and
Like you write
uh,
it down, right?
yeah, I was expecting to pass a double. Still, when I pass an integer, it's not throwing an error. Why?
Yeah, because double you can take to both of, point and integers.
Yeah, that is correct. Like when we assign something like double, we can initialize integer. But if this was like integer, if this was integer, and if we had like passed double, that would be throwing an error. We had already seen this while we were studying data types, right? Implicit conversions, explicit conversions, typecasting, those things, right? Remember those days when you studied data types, those typecasting and which promotion of data types, demotion of data types, those slides, right? So that is why a double can basically take any integer value. There's no issue about that. Got it?
Yeah, right.
Yeah. Okay. So this is fine. Okay. So we had covered these constructors. So let's get ahead with the next concept. Let me see what was the next thing. We had covered method overloading, we had covered constructors, and next is init blocks. Okay. init blocks constructors. Okay, so init blocks is basically a initialization block, and this will be a block of statements that appears within the class declaration outside of any member or constructor declaration, and which initializes the field of the object. It is executed as if it were placed at the beginning of every constructor in the class, with multiple blocks executed in the order they appear in the class. In practice, initialization blocks tend to be used for non-trivial initialization when constructor arguments are not needed and there is a reason not to be provided an argument constructor. So, what this basically means? This means that these init blocks are also used for initialization of data members. So, what was the role of constructors? Constructors were also used for initializing the data members. Suppose we have created some instance variables. We created some instance variables, right? Like name, age, salary. So this needs to be initialized. This needs to be provided with some values. So we created constructors, we created a default constructor, we provided some values, and then we created parameterized constructors and provided some values. But why basically we need initialization block is initialization blocks will basically be needed sometimes when we don't need to create a constructor, when we basically don't feel the need to provide a no argument constructor. So there will be use cases when you will be basically having multiple blocks to initialize. So you can create any number of initialization blocks, and those initialization blocks will be simply like with some curly braces. You will just provide some initialization of variables, initialization of instance variables, so that will be init blocks. And you can like create a number of init blocks, and the order of execution will be in the order that they created. Suppose you have like 4 init blocks. I'll show you like when I take the demo example, right? I'll show you like what I mean by those. But the order of those init blocks will be the order in which they are created. So whatever initialization block is in the code first, that will be executed first, and then whatever is in the second block, that will be executed next. So I will show you this with a demo. I'm creating a package. Okay, so let's go ahead and create a class called student. See, remember earlier we used to create a constructor to initialize something. Now what we'll basically do, we'll just write a pair of curly braces. This is just a pair of curly braces, there is nothing. See what it's basically, this is giving me some suggestion, the editor is giving me some suggestion like class initializer may be static. So what we'll basically do, so what this means is this is a static initializer. So since we are creating a init block here, means in the class this will be a static initializer. So this is a static variable. So a static variable can be accessed by any methods, like any type of methods. It can be accessed by like non-static methods or static methods. But what we basically want to do, we want to access this, we want to like initialize this id num now. So let's go ahead, initialize this with the value of next id, or we can do a next id plus plus. And next thing what we basically want, the next whatever is like remaining, the remaining parameters, we let's go ahead and initialize using the constructors. So that can be also done. String name this dot name equal to name. Let's go ahead and create a main method. Let's create a object of this class. See, when I created an object of this class, do you see any error? What this error is basically saying, it is expecting one argument, but I have not provided that argument as of now. So what I will basically do, I will provide an argument here. What argument is it expecting? It is expecting a string. When I say like student equal to new student and provides a value, so this will basically go ahead and call this. Let me go ahead and print. Okay, see, name is Andrew. Now let me go ahead and print id. See, this is this is also getting initialized, right? So this is init block initialization, and this is constructor initialization through constructors. So this way also you can initialize. See, this is one init block where we just provided a pair of curly brace and we initialized this particular instance variable or non-static variable or data member, and again we created an parameterized constructor and we initialized name. So this can be also done. So to when an init block is created, now uh, you don't need an object to again initialize. You have like initialized it here itself. So when you access it using a object, right, you will get the value student dot id num. Why? Because you have already executed this init, you have already initialized this init block. One more thing, like you can have like number of init blocks. You can have a number of init blocks, like you can again initialize something like this. So when you try to run this, see what happened. We had initialized this value to 1 at this line number 10, right? But again in this init block, what happened, I initialized it again to some other value like 85. So what happens, the value which was already with id num, that got overwritten at line number 14. So say next id plus 10. So what is the expected output for id num? Initially it was 1, right? So now plus 10. So that will give me a value of 11. So so you can have like number of init blocks. You can again have something like this. So what happens now, id num will be again overwritten. Okay, one second.
So, mhm.
Okay, id num is a static. Okay, one second. id num, this was like giving me a value of 11, right? Let me create another init block. Let me create another variable. Uh, long marks. Or integer marks. Assign it a value of like 10. Now marks plus 20. Okay, I have some syntax error. So the initial value was like assigned to 10, and then I have incremented the value with 20. So the expected marks is like 30. So you can like have number of init blocks. So the order of execution will be, first this will be executed, then this will be executed, then this will be executed. And init blocks, one more thing, like init blocks are executed before the constructor. Before the constructor, like even before the object creation, these are like executed. And then what we saw, there was this way of initialization we had already seen. This was like through parameterized constructor. So when we basically call this class using one parameter, so this parameterized constructor is called. So this is how we can basically use init blocks and parameterized constructor for initialization. Got it? Next, we'll see what is basically static methods and fields. Anyone has any doubts in this one?
Um, I mean, in the top, I mean, 11 is override, right? So all assign out, all assign out to get out. I mean, 11 and 30, right?
At line 11,
Yeah, I mean, printed the ID 11, right?
we printed
The
the ID. We printed the ID here, right?
Yeah, on the top is 10 plus 1.
Yeah, this is like next ID 10 plus 1. So this is
But
11.
yeah, but it's override. It almost override, but only expected only 30 mark.
No, next ID was like initialized with a value of 1, right? So 1 plus 10 is 11, right? We initialized it with a value of 1. So 1, this is 1 plus 10 is 11.
Okay, for mark is 10. Okay.
Yeah. Initially I had like put it at 0, that is why you might have been confused. So this is like 1 and then I added plus 10. So 1 plus 10 is 11. Okay. When we can modify static next ID. Okay, we are going to teacher, we are going to see the application of static now. So I'll cover those things now. So this was on init blocks. Now we'll see what is basically static fields and methods. We had seen this init blocks. Now we'll basically see what is static methods and fields. So a static member is created only once per class, irrespective of the number of objects of that class. So static, even if there are no objects created for the class, the static fields are created and are available. The static fields of a class are initialized before any static field in that class is used and before any method of that class, including the constructor, is run. So see, when I say anything like static, when I say something like static, you have to understand that static is something related to a class. Static, when I say something like static, you have to understand that it is at class level. Static means something at class level, and you don't have to basically create an object to access a static method or a static variable. So static means at class level. When I create any static variable at the class level, it will be basically available to all the static methods and all the non-static methods. Got it? See, similarly, a static method of a class can be called even without an object of the class being created. This is what I was saying, right? You don't basically need an object to call a static method. A static method can access only the static members of the class. So, what will happen when you create a static method? In that static method, you can only access the static variables. So if you try to access any non-static variables, you will basically get compile time error. I will show you those things in the demo. Similarly, a static block is implicitly invoked as soon as class is loaded and before object instantiation. So what this means is when any class is loaded, even before any object creation, whatever values you have, whatever variables you have with static keyword, those will be initialized and those will be available to you. Even if you don't create an object, those static fields will be available to you. So why? Because that is at class level. So such a block is useful to perform necessary initializations of static members like static methods. Static blocks can also refer to static things only. Observe the following example. Static blocks are not for trivial initializations. If you want the array be initialized with prime members and not mere zeros, static block is at our help. See what happens sometimes in when you go for like real-time projects, you will need to use the static variables. Suppose you are like creating some constant values which you don't want them to be changed throughout the class, means you want to basically make the same value available throughout the class. So at that time what you do, you use the static keyword, and also with static keyword you use something called final. You use static and then final as well, but I'm not talking about final. But when you create some variable a static in the class, that will be like available to you through the entire class. So that is the application of static. So let's see this example. What is basically, we have a bank account class, and then we have something as account number. So see, account number, ACC number, this is not static, right? Because we do not have any static keyword in front of this. Then we have something like float current balance. So this is non-static. Non-static means which does not have a static keyword before the data type. Now public static int id num equal to 1000. So we have initialized a static variable to id num to 1000. Now what we are basically doing, we are creating a constructor. So public bank account, this is a constructor, right? Remember this is which type of constructor is this one? Public bank account is which type of constructor? Is it like default constructor or a parameterized constructor? Anyone? Which type of constructor is this? Public bank account. We are not passing any parameters. So which type of constructor is this? Yes. Yes, TJ, that is correct. This is a default constructor. And why? Because we are not passing any parameterized any parameters over here. So this is a default constructor. This is like straightforward, right? We are not passing any parameters in this. So this is a default constructor. So see what basically we are doing over here is like this account number. We are basically initializing account number equal to id num plus plus. So id num is 1000 and we are initializing account number with 1000 and then incrementing this id num and current balance equal to 100. So public static int get id num. What do you expect the value of id num will be? I'll show you. Let's create this example. We'll see. I'll create another package. Uh, since static is a Java keyword, if I use it, it will throw me an error. Okay. Okay. Let me see if it is. I will delete this. Okay, I'll create the same bank account class now. So I'm creating a variable like account number. Now I have something like current balance, and now what I'm doing, I am creating a ID. An ID I'm assigning to, suppose set n. This is a static keyword, right? Remember, this is static variable. Now what I'll do, see, I've shown you like we can create a default constructor, right? There's another way. The editor provides you some help which you can do. When you right click, right, and then you see this generate option. When you go on generate, and when you see this constructor, right, okay, this will help me to like create a parameterized constructor. But let's say I'm just clicking on OK. So this created a parameterized constructor for me. You saw, right, what I basically did? Right click here, generate. If you want to like generate a constructor with both the parameters, right, select both this and click OK. This generates this block of code for you. This editor will basically generate it for you. As of now I was like writing it down. Why? Because that helps you to like understand. But when you create like real-time projects, so you can basically go ahead and create it like this, because it auto generates this for you. So as of now, I suppose I don't need this parameterized constructor. I just need a default constructor. So I am removing this parameters and all. So let's say I am taking this account number, and what basically I'm doing, I am printing out this. I am creating another method, public static, and the data type that I want to return is basically integer. So what I will basically do, get ID and return ID. I'll do this. See, this is a static method. This is a static method. This is the name of the method. This is the return type. And before the return type, you will have a static keyword. So this is a static method. Static method. What I'm basically writing, return ID. Okay, one more thing. Let me try to use what I'll basically do. I will try to use this account number variable and write down 100. See, this is throwing me error, right? Why? Because this is the error. Non-static field account number cannot be referenced from a static context. See, this method is static. In a static method, you can only access static variables. You cannot access non-static variables. But in a non-static method, you can freely access any static methods or non-static methods. Suppose say I create another method, public void print, and I try to like access. I want to basically print ID, so I can print ID. I want to print account number. I want to print account number. So account number. So one thing is to, this is a point to note, static methods can only call static variables or methods, but non-static methods can call both static or non-static variables or methods. This point is very important. Sometimes you might be asked in an interview, and there might be some code snippet given where they might test your knowledge that whether this can be accessed. Some objective type questions might be asked where they will basically provide you a static method, and they will try to like access some instance variable like a non-static variable, and they will try to see if you are able to find out whether you will be like given four options like this syntax is correct, this will be able to be accessed, or you will get some compile time error. So such options you will be basically given. So you will have to basically understand that static fields can be accessed from any non-static context as well, but in a static method means the static variables can be accessed from non-static methods as well and static methods as well, but these instance variables or non-static variables, these need to be accessed only through a non-static method. These cannot be accessed through a static method. Got it? Why? Because these can be accessed when we create the object of the class, and using that particular reference variable we should be able to call this. But this static keyword, this can be accessed with the class name as well. Okay, what we'll do next is we'll create a main method. We'll create a main method and we'll create the bank account class object. Okay, bank account dot print. Okay, I'm getting some make print return boolean. Okay, why is this? Okay, got it. Sorry, my bad. Bank account dot print. Yeah, so we are creating the object, and through object what we'll basically do, we will call this print method. See, this is non-static method, so non-static method called through object creation. Now what I told you, when we think of static, when we talk anything about static, right, what you basically need to understand is static is something related to a class, and whatever is related to a class can be accessed with the help of the class name. So let me try to show you one thing. I'm using bank account dot get id. Why I'm able to access this get id is, see, bank account is the class name and get id. So let me try to do one more thing. When I write bank account dot print, this throws me an error, right? This throws me an error. Why? This is a this is a non-static method, and a non-static method will be called only through object creation. So this is throwing me error. But this is a static method. Get id is a static method, right? See, there is some static modifier here. So it can be basically called with the help of the class name itself. So static method does not require objects to call, does not require objects, does not require object creation. It can be accessed by class name. Static method does not require object creation. It can be accessed by class name. So we are able to access this one. Okay, one more thing. Our static variables initial value was 10. Now when we basically print, what is the value do you expect? Can you tell me why this printed 11 and not 10?
id is incremental, id plus plus.
Yes. At line number 10 in this constructor, what we are basically doing, we are incrementing this id, right? id plus plus. So that's why it's basically printing me 11. So see this class. We saw multiple things in this class. This is a non-static variable. Non-static variable. And this is also a non-static variable. And this is a static variable. And what we basically did, this is our constructor. This is our constructor. So we are initializing one of our non-static variables. So account number is equal to id plus plus. So okay, what is the value of account number if I print it? Will it be 10 or will it be 11?
I think 10.
Yes, 10. Why? Because first it there is some difference, right? When we do plus plus id and when we do id plus plus, what happens when we do id plus plus? This value is first assigned, the initial value 10 gets assigned to this account number, and then the value of id becomes from 10 to 11. But if I do something like this, let me comment out the previous thing. Now what will be the value of account number?
I guess the same thing doesn't change.
No, this is not the same thing. This is not the same thing. See now you will see the difference. I'm running it. Account number is 11, right? I think
Yeah.
I've taught you this while I was teaching you operators. What happens? See, when I do plus plus id, id first gets incremented to 11 and then it is assigned to account number, right? But when I do id plus plus, so see, this plus plus means plus plus after the variable means that this will be first assignment will take place. The value of id was 10, this will get assigned to this account number and then this will be incremented. So this is called, I will write down in the documentation, postfix increment first assignment and then increment, and this is prefix increment. Prefix increment, first is increment and then assignment. Is this clear? Hello?
Yeah, that one's.
Yeah. So see, we have two non-static variables and we have one static variable. And then what I've basically done, I've created a default constructor. In this default constructor, I'm basically initializing one of our non-static variables. So id plus plus will basically assign a value of 10 and then id gets incremented from 10 to 11. And when I do this public static get get id, what I'm basically trying to do, I'm trying to return the value of id. So id was initially 10. Here we basically went ahead and incremented, means id plus plus was incremented, means postfix incremented. So at this point the value after increment will be printed. So we have like another non-static method, so what we are basically doing, this non-static method, we are able to call all the variables. Like a non-static method can basically call a static variable as well as a non-static variable. See, id was id was static, right? And account number was non-static. So both are accessible in non-static methods. This is a non-static method. And but here, right, in the static method, when we tried to access this account number, we were getting error. Why? A static method cannot access non-static method. Account number is non-static and this method is static. So that was like giving me compile time error. And now let's come to this main method. We have created an object of the class bank account, and we had called this print method. So we will basically use an object to call non-static methods. And see, this get id method, this get id is a static method, so we can simply call it with the help of class name dot get id. We did not use this object reference to call these static methods. Also one thing, we can use bank account dot id as well. Why we can access simply with the help of the class name? Because this is a static variable or static method. Static variable or static method can be accessed simply by the class name, but you cannot call a non-static method or a non-static variable using a class name. You need objects for that. So I will write down in the documentation. Static methods or variables can be accessed by class name, but non-static variables or methods require object creation. Is this clear? This class has like a lot of concepts. I have demonstrated a lot of concepts here. So if you feel like anything you have not understood, you can let me know now. Just go through this program once and try to see if you have like any doubts. Okay.
Rita,
Yeah.
sorry, still I have a little bit confusion, non-static and static.
Okay. Yeah. What is the confusion, Gesa?
Uh, Non-static and static.
Okay.
When we say non-static and static.
Okay. I'll again explain. See, one thing is, when I say something like static, it means that static means something related to a class. Remember this. When I say something is static, a variable is static, a method is static, that means it is attached to a class. Think of this. And when I say non-static, non-static means that has something to do with the class object. So you understand this, right? Class object can be created something like this.
Yes, yes,
This you are clear, right? So
yes.
when I say something as non-static, see, non-static variable does not have any static keyword here, right? But a static variable will have a static keyword. Private static data type variable name is equal to some value. But a non-static variable does not have a static keyword here. This is clear? I guess
Yeah,
so.
so based on,
Yeah,
yeah, so when declare, so based on the requirement,
yeah,
yes.
yes. Based on the requirement, will basically declare. So static variables you might require sometimes that your variable is available to you throughout the class. Your variable is available to you throughout the class, and you have simply declared some static variables which you want to use throughout the class. So you can like create a static variable in that case. Now see, these static variables or static methods can be called by any static method and also non-static method. But when I have a non-static variable or a non-static method, this is non-static variable, right? And this is like non-static methods. This must be definitely called using the object only. This is the object reference. Only through this object reference we will be able to call this non-static variable, no, sorry, non-static method. Or when I go for bank account dot c account number, right? This can also be accessed only through the, means this is like, I can just put it in a print statement. So bank account dot account number. So this account number is a non-static variable. So this must be accessed using the object reference variable. Is it clear now, Gaso? Or
Yes.
if you still have
Yes.
any doubts, you can ask, because these are like very important concepts. Anyone else has any questions about this? Okay, so we have covered static methods and fields. And see, this is main method. So we have been like widely using main method ever since we started seeing the demo example. So we are like we have created these main methods until now, right? See, to run a Java program, you need to specify the name of a Java class that drives the application. So when you run a Java program, the system locates and runs the main method of that class. The main method must be public, static, and void. It returns nothing. So void means no return value, right? Void means empty return value or no return value, and must accept an argument of type string. See, when we create a public static void main method, right, we will always pass this string variables, string arguments here, like string opening closing brackets and with this args. Why? Because JVM or the JVM, Java Virtual Machine, this basically recognizes that this public static void main, if you have this exact signature, then the JVM recognizes thus that this method does not require any object creation or anything. So whenever your class is loaded, basically this main method will be loaded. So each class in an application can have its own main method. However, only one main is used at a time because you supply the name of the same class to run. This provides a convenient way to include hooks for unit testing individual classes. So, see, whenever we create a main method, public static void main, why is it static? Because we do not require an object to call this static methods. And whenever we provide this signature public static void main with the string arguments, the JVM or Java virtual machine basically recognizes that this is a special main method, and this will not require any object to call this method, and it can be simply this method, static method, will be loaded on class loading. So when you like run your class, you don't need to basically call this main method. So this main method is special. You don't do you see that ha- have you any time like call this main method? No, right? We are not calling this dot main anywhere, but this gets executed, right? this main method always gets executed. We have suppose this is like print method, or this is like get id. We are calling this method, right? See, static method we are calling with the help of class name bank account dot get id. Then again this method as well, like print method, we are basically calling like bank account, means with the help of reference variable dot print we will call this. But this main method does not need to be called. This gets called automatically by the Java virtual machine when this particular syntax is encountered. So this main method is special. Upon class loading, this method gets called automatically. So this has some applications as well. So basically you can use some kind of like in unit testing, right? Sometimes this is helpful. Means when you have a lot of project and you want to just test it out something, you can just test it out in the main method. Means we'll see those things when we create the projects, but this is about main method. Then we had seen like init blocks, right? We had seen init blocks, like this was init blocks. We were basically initializing the variables, where we were basically initializing variables. Now there is static initialization blocks. Static initialization blocks, this is like similar to init blocks only, but there will be slight difference. So static initialization block is much like non-initialization block, except it is declared static, can only refer to static members of the class. For example, creating a static array and initializing its elements sometimes must be done with executable statements. And the static members are also executed when the class is loaded. With this guarantee, our static block in the example is assured that our non-primes array is already created before the initialization code block executes. Okay, so let's see this example. We have a class primes, right? We have a class primes. So we know this concept now, that when we talk about anything like static method or static variable, right? So in a static method, only the static variables can be accessed. In a static method, only the static variables can be accessed. So similarly, in a static initialization block, mainly you will always use static variables only, or any static arrays that you have, or static variables. Only those you will use to initialize in static initialization blocks. So see, at in this example, there's a known primes array, right? We have created an array, integer type array, and the size of that array is 4. You all people recognize this syntax, right? This is creation of an array, right? Int square brackets, then variable equal to new int 4. So this is how we declared array in that class, right? When we demonstrated the example of arrays. So this is static initialization of an array. So see what basically it is doing. At index 0, we are basically assigning a value of 2, and we are doing this in a static block. So in static block, we are basically initializing our static variables or static arrays. So in an init block, we already have a package, right? So let's static initializer. So let's create some private static int num equal to 0, and we were used to have this init blocks, right? So we will just include a static variable before this. So static. So now this is static initializing blocks. This is our static initialization block, and we can basically, let's say we did not initialize some value here, we will initialize the value here. So we have provided some value to our static value, and now if you want to print this, how will you print this? Let's try this. 0. Okay, now if I put it this 10, this is 10, right? So this way we can do. This is a static variable, and we had initialized this value in a static block. So this is similar to the init blocks that we saw that had just curly braces, but those blocks will be, these blocks we will basically use init block initialization. So used for initializing non-static data members or variables, but static initializer block used for initializing static data members or variables. So this is about the static initialization block. There is, when we basically use static initialization block, when we basically use non-static initialization block. Static initialization block is used for initializing static variables. Non-static initialization block is used for initializing non-static variables. And also, like static, these blocks, if I create some constructor in this class, suppose I create some constructor in this class, and I have a static initialization block. So which will be executed first? This static initialization block will be executed first, and then this object creation will be done. So this static block is basically loaded upon class loading. So this gets executed first, and only then the object creation is done. Now let's see another thing. This is a simple example like variable arguments. Are you okay like if I extend the class with another 10-15 minutes, or is it like too late for you? Okay, we'll extend the class for like 10-15 minutes. See, this is where args. Where args means variable arguments. So see, this is the example. Means we can like provide some variable arguments. Suppose we want some variable to like hold some multiple values. When I say this, what I mean is like when I write this syntax int dot 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 x, so that means that expects from 0 to as many integers as parameters. So that is like providing variable number of arguments. So also one thing, when I provide some variable that expects variable number of parameters, that means that that must be the last parameter in that method. So see, there are some legal definitions, there are some illegal definitions. Why? Because see, void do stuff. Void do stuff is basically anti dot 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 x expects from 0 to many integers as parameters. Now when I see void do stuff to char c integer dot x, see, first parameter is character. First parameter is character. This will expect only one character value. Then this int dot x, this can have like multiple values. I will just create some package where args. So I've created one print method where I am taking one character as a parameter and I am taking this variable argument. So variable argument means when I say dot, so you can like pass 0 parameter only, or you can pass 1, you can pass 2, or you can pass any number of parameters. So that is what it means by variable parameters. So let me create one object of this, and let me copy this here. Here x equal to this one. Okay, one second. So we are printing the value of character as a, and then we are printing the first index, means at 0th index whatever value we have stored. So at 0th index we are basically storing 1. So this is like simple example, like this print method can take this character as an input and then any variable number of arguments. So variable number of arguments you can basically pass using array as well, right? So this is like passing an array. So let's try to see other example, like void print variable arguments. Let's try to now reverse this. Let's try to now reverse the order. See, it started throwing error, right? Why it started throwing error? Because whatever variable number of arguments you have, that must be the last parameter in the list. Means this is like accepting variable number of arguments, right? So this must be the last parameter. If you provide it before the last parameter, this will like throw you an error. So error as variable argument parameter is not the last parameter. Got it? So this is illegal, this is wrong. So similarly, if you see this, right, illegal 1 second do stuff, what they are basically doing, they are providing the variable arguments in the first and the second as well, but this variable argument must be always the last parameter only. So this is that means whenever you want to like create any variable argument, try to place that in the last parameter of the method. Any questions on this one? Okay, so this is this is like enhanced for loop. This we have already seen. Using enhanced for loop we were trying to print an array as well, right? So similarly you can print this variable arguments as well using this syntax for anti x colon v. So we had also printed an array using this syntax. This is enhanced for loop, so you can use this syntax. And see, this is static void test. This is a static method, right? So static method can be directly called in a static method. You do not need an object uh, to call this static method. So this is one static method, public void static void test. This can easily be called like this. This can be easily called like this using test, using the method name and then providing the parameters. So static methods do not require object name. Uh, Static methods do not require object creation to call them. Okay, we'll see the next topics in the next class. So that will be it for today. We'll start from garbage collection and then there are like few topics left. So mostly this classes and objects will be done tomorrow, and then we'll also start uh, some next topic like extending classes and inheritance. Inheritance is also like a very important concept, so we'll see that tomorrow. Do you all have any questions from today's class?
I see the agreement for that.
Sorry, what?
One of the agreement. Yeah.
Uh,
Scenario.
you want to again visit?
Yeah, agreement. No, that's the one.
Okay.
No, because no, that's the one. I mean, you calling it.
You want to see the editor?
It's the scenario. Yes.
Okay.
Yeah, we're looking for the agreement. That's that's voice. The first one is synthetic, right? I mean the statics. The second one calling static. I mean the statistics, right?
No, no. See, this method, right?
Static is yeah. Because I cannot call for the statics
No,
number
no.
directly.
This method is not static, right? This
Yeah.
this method is a non-static method. So a non-static method always requires an object, right, to be called them. So we created the object of this class, and then using this reference, we are trying to call this print method.
Mm,
Now,
okay.
if I have a static method, see, static void test, I'm just using a print statement. Print, sorry, print hello world. So I do not require a object to call this method. I can simply, I can simply go ahead and
And then the statistic.
uh, just just do something like this, and this will print it. See, see, you are able to print this hello world, right? You did not need this reference variable to call a static method. Since this is a static method, this can be easily called in a static method. In a static method, you can simply go ahead and create another call another static methods. So that is straightforward. Why? Because static is something related to a class, and it is available to you in the entire class. So you can simply call something like this. This is also a static method, right? Public static void main. So this is also a static method. So you can simply go ahead and call this. If you have any variable as well, you can call this in static method here. But a static method cannot call your non-static
Wait.
variables. So
Okay. Yeah, I got you. Yep.
if I try to access this number here, number, I would get error. See,
Yep.
non-static field number cannot be referenced from a static context. So this will throw me error. Got it?
Yeah, I got it.
Static, non-static, these concepts are clear, right?
Yep. Yep. I got
Yeah,
it.
these are
Mm,
like important concepts. Okay. So we'll keep this class until this topic only. We'll start from garbage collection tomorrow, and we'll see inheritance and other topics as well. We'll have the class at the same time tomorrow as well. So whatever assignments or exercises I've given, try to like practice those things, because those are important. Those will like help you in understanding the concepts more clearly. You will have like hands-on practice as well, so that will be like very helpful and beneficial. Okay, yeah, I'll conclude the call for today. Thank you everyone.